Hello everyone, welcome back to the session. This is Gyanendra and we are here back with another lecture in the series of our IIT JEE preparation. Okay. Yeah. So it has been long that we have been doing and discussing about different chapters of the organic chemistry. We did talk about alkane, alkene, alkynes, right? We did cover up that part already. So hello Vishal, hello Mighty Sharma, how are you? Hope you're all healthy. With that, we'll just be talking about alcohols chapter. This thing particularly has helped a lot really in the last year. I mean, the last 2 years, you guys and all of us have been like washing our hands and like having it cleaned using this hand sanitizers that is an isopropyl alcohol. So it has been a long that this alcohol is supported as not in the way that we drink it, but in the way that we could use it as a sanitizer because of its disinfectant and unique properties. Hello, Ujjwal. How are you? So, this alcohol is one of the very important things, not as a beverage, but also in medicines, and it really has a variety of uses, guys. Okay. Thank you, Ujjwal. Yeah, so what I was trying to tell you was this alcohol can help you in really a lot of ways, not just for drinking. Again, I'm telling that because many other places are there that it could benefit us all a lot. Like if you go to a laboratory also, people would use this alcohols a lot. Like not for the drinking purpose, but for cleaning purpose. The same has been done last year. Now, why is this alcohol important is because of its unique nature, because of its type of molecular bond that it has, because of its properties, right? We'll just understand all of it now or today. Basically, we'll be talking about what is an alcohol, what is it that makes it unique and different from other things. Apart from that, we'll also understand how do the alcohol react. And like, yeah, today, as we are talking about just the preparation, we'll be covering up to the preparation or till the preparation part. So till that, if any of you get any doubt, do let me know in the comment section or the chat box. Be with me and yeah, do like, share and subscribe. So this is me, Gyanendra Sahu, and I have been in teaching industry for around 7 years. I've taught in many big places, small places, different type of places. No, it depends on the students also. So yeah, so I have been in these places and I know what is it that you have to use or learn in order to understand the chemistry really well. Okay, then yeah, let us start with this understanding of alcohol. We have only, even when we say alcohol, the only one thing that comes in our mind is this one over the corner bottle, right? But in reality, alcohol is simply a compound containing this OH groups. I'll just show you how and what does it show differently. So the CH3, I'll just make up a normal alcohol, although it is dangerous if you drink up, okay? CH3OH is what we call as an alcohol. So if you look at this alcohol, it has this OH bond attached, children. If you look at this, you all know oxygen is an electronegative element. What does it mean? It has an affinity towards a bonded pair of electrons. It would try to attract it towards itself and it would definitely keep it towards. And because this oxygen is going to keep the electron pairs that are going to be over here more towards the oxygen atom, it would result in this carbon and oxygen gaining some partial charges. You guys might know that this sign literally means del, it means very small, right? For those who are not aware. So yeah, so this would gain a del positive charge, a partial positive charge. On the other hand, since the electron density has come over to oxygen, they would gain what charge, children? Partial negative charge. So what is the benefits or why are you telling us the charges? Guys, you should understand because of these charges, all the reactions of alcohol get affected. These charges are the ones that decides what kind of reaction do they give. You may many times ask me, sir, I don't remember things. How do I do it? I mean, I don't remember an organic reaction. I don't remember the reagent. Guys, it's this molecule. If you understand that, you could understand what is it that the reaction would have if this is getting reacted. So that could help you, children, right? So since this is a bond which is polar, if this bond gets broken down from here, you guys might know. It's like this. If you have a friendship with a very powerful person and this friendship turns into an enmity, when I mean, you make him as your enemy and the bond breaks. This guy who's very powerful would take up more of the things that you and him had shared, right, children? So these partial charges do have an influence over how the bond or the process would progress if they would react. That's why it is important. Yeah. Now this hydrogen over the corner does also have partial positive character compared to oxygen. Yeah. But then yes, these things are going to really help you a lot in identifying the kind of reaction that they would give you. Okay. So let us just understand more about it. So we have now understood like what charges do these atoms in alcohol have, right? Okay. Yeah. Now this alcohol functional group, if we drink it a little, very little amount, you might start feeling dizzy. Now this alcohol is dangerous. If you take it a little amount also, instead of feeling dizzy, we may even get affected in other ways. So this is ethanol only that we could tolerate to a certain level. Not in our country, in cold countries, they may need it for certain reasons, but not for us. But anyway, let's move on. Yeah, different types of alcohols are there, children, because you guys have seen them. You may have a primary alcohol, a secondary, a tertiary alcohol. Can't have a quaternary though. Hello Aditya, how are you? Welcome to the session. So if you observe over here, if alcohol is attached to a carbon, which is only attached to one carbon, if you look at this carbon, it has only one carbon attached to the, such a carbon is called as primary carbon. And since alcohol is attached to the primary carbon, it would be called as primary. Similarly, the carbon over here is attached to two carbon atoms. So what kind of carbon is it? A secondary carbon. Right? So the alcohol that is formed over that is going to be a secondary alcohol. Hope that is also clear to you. The last one over the corner, in that you could just see that over this carbon there are three alkyl groups attached. And because there are three alkyl groups attached, well, what do you think that alcohol is going to be? Definitely tertiary. Yeah. So that is the way we could decide, children, like if the alcohol is primary, secondary, or tertiary. Like you could clearly or easily decide that out here. I hope that had made sense and you've understood it. That's a very simple thing. They won't ask you that in IIT. Yeah. That's it. What is that is important for us? Is like we just understanding the basic now. Slowly we like move up the ladder and then you'd understand what is more important. Okay. Now then there is this dihydroxy. Guys, remember diols are one of the very important topic and favorite of IIT JEE. I mean those persons who prepare the question. Diols literally means di-OH. Two OH groups are going to be there in the main chain. Such a compound is called as diol. And you would mostly have it over the adjacent positions. And that would make a lot of changes. It would come across a lot of reactions while we'll be doing or when we'll be doing the reactions. There's a very famous or unique reaction. Many of you might already have heard of it, called as penacol-penacoline rearrangement. That's one of the very important reactions, and IIT JEE love to ask questions from them. So you guys should understand that, yeah, there's some small topics that wouldn't take much of an effort to learn, would give you or fetch you a lot of marks. So remember or note that down, that diols are important. Triols are also not important though. Okay. Triol literally means having three OH groups. Okay, so I don't think I would have to focus more, put more effort on telling you that, okay, three OH is what is tri. So hope you guys are understanding what I'm blabbering, what I'm trying to teach you, and you're going to get benefit from it. Okay. The next is this physical state, okay, or the physical properties that is shown by alcohol. If you guys would have seen an alcohol molecule, I mean, not in reality, but in the compound form like this, which I'm making over here, you can see that there is this hydrogen attached to oxygen, okay, and because of there's a lot of nature of this compound gets affected. How? I'll show you that. Because this is having a partial negative and a partial positive charge, this compound is definitely polar. That means it gets dissolved in all polar substances. Not just that, they usually have a faint odor. I mean, you would have felt it when you would have used the hand sanitizer. Right? I mean, although they would have added some type of some substance that has its own flavor or odor, they would have added, but then yeah, this alcohol themselves would have a strong smell. Okay, and yeah, they're really good, I mean, substance that could get burned well, so they're flammable. That's why that you're supposed not to spray alcohol or sanitizer over the fire, right? Instead, what you should do is you should throw some water. And yes, if you see there is no complete charge, for that reason they're definitely neutral. So this is the case, children, that you guys need to understand, and these properties that are important aren't this. Property that are important are going to come up next. Let's just see that. Property that is important is its boiling point. Now you just imagine there are three friends, children, okay? First, I mean three set of friends. The first set of friends is just hi, hello type of friend. They would just say hi guys, how are you? That's it, nothing more. The second set of friend is like hello, let us just move to here. I mean they're like much closer friend. And the third one are like childhood friend, and they're like no matter what you do, they're not going to leave each other. So you could just understand, depending upon this three type of friend, whom do you find most easy to break? Like which type of friends could you separate easily? I mean, many times it may happen that if you want a good friend, you would have to enter in the friendship with others. You may not need to break that friendship, but then you need to enter. So what I mean is, if these two friends are really, really close, breaking them away, moving them away from each other is going to be really difficult. Okay. The alcohol molecules, if you observe, would have this polar bonds, and polar means definitely they would have partial charges, and we already have an idea. Opposite charges attracts each other, and this would have real good attraction. We know this by another name, like this attraction is called as hydrogen bonding, if you remember. Hydrogen bonding is the strongest type of dipole attraction, children. And if this is the strongest type of attractions out of the ones that gets that, other than the covalent bond, hello Shankar, how are you? It is going to be holding the molecule really, really well. So breaking them requires a lot of effort. So what you have to understand here is this molecule are really well bonded. So if you compare them with alkane, there is no question of comparison. Alkane can get evaporated on its own. They can get away from each other really easily. And that's because of no attractive forces, or just the van der Waal force of attraction. Haloalkanes do have dipole attraction. I'll just write it over here for your knowledge. Do let me know if you're getting the ideas, you're getting confused, or whatever it is. You just let me know, children. And also let me know which color is visible, so that you can use that. Yeah, so alkanes would have only van der Waal force of attraction. Van der Waal force of attraction. How about alkyl halide? Alkyl halides, or haloalkane, which we call them, would have dipole forces of attraction, holding two haloalkanes together. How, sir? I don't understand. What do you mean, really? Let's just see that as well. CH3Cl and another molecule, ClCH3. This just has partial charges. Okay, partial negative, partial positive, partial positive, partial negative. Because they have opposite charges, there would be an attraction created. This is partially positive, this is partially positive. Now, because of this, there would be an attraction between the CH3 over here and Cl over here. And this attraction just causes molecules to be attached to each other with a more strong bond compared to two alkanes, which don't have this type of partial charges, because that is non-polar. And in the third case, it is the strongest of these partial charges that you may get. This oxygen is really very electronegative. Apart from, other than fluorine, it is most electronegative. So it would abstract the electron density all from hydrogen, almost all. For that reason, that hydrogen would get so much positively charged that it would really well attract the oxygen. And for that reason, the ones where you'd have hydrogen bonding gets bonded so strongly that breaking them requires a huge amount of effort. Okay. And for that reason, alcohols would have the strongest of attractive forces, causing them to have strongest boiling point, or largest boiling point. Hope that made sense and you got that idea, right? So let us just move further to the next thing. Now, yes, one more thing. If you want to be with some group of people, in general in school, what happens, there are people who like cricket and who like IPL. I'm not into them though. There are people who like football, soccer. There are people who like basketball. If you want to be in basketball group, would you be going to be there? I mean, in India it is possible, but in other countries, if you want to be in a basketball group, would you be sharing your cricket knowledge with them or basketball? It's very simple, right, children? To be in a group, you would need to be like them. Here, this alcohol molecule has this OH bond, okay? OH bond, and water also has this OH bond. I mean, not OH bond is important here. What is important is hydrogen attached to an electronegative atom is present over both the groups. And for that reason, what kind of bonding do you think you would have here again? Hydrogen bond. And this hydrogen bonding is really good bond. I mean, I'll tell you one story about hydrogen bonding. I mean, it is not a story, it's just a reality. You guys might know that the boiling point of water is what? Could anybody tell me? Hello Ankit, how are you? Welcome to the session. Hello Religious, welcome to the session. Hello Religious, hello Krishna, how are you guys? Welcome. Yeah, so what I was trying to ask you, what do you think is the, I mean, do you know the boiling point of water? Everybody knows it. The boiling point of water is around 100 degrees Celsius. But that is a boiling point which is much higher than any other member of the hydro, I mean, the same group. If you go down, you'd not have that much of a boiling point for any other member of this thing. Then why, and what does make alcohol have such a high boiling point? You know, without a thing that I've just taught you, without something called as hydrogen bonding, the boiling point of water would have been really low. You could not even guess how low it could be. Could you guess? Could anybody give it a try? Let me know in the comment box. It would be around negative 80 degrees Celsius. It would be so low that we can't even imagine that water would be there in the liquid form on earth, right? If boiling point would have been minus 80, all the water would have been vaporized and we would have not had any water to drink. Would we have survived on earth? All right. Then why and how do we have this survival possible? It's because there is this hydrogen bonding which holds the bond of water really well. Without that, they could have boiled really easily. So they could have broken easily. But because of them bonding really well, you have them held tightly and they don't get broken easily. And because of that, the boiling point has moved from minus 80 to over 100 degrees Celsius. And that's how we are all thriving on earth, right? You're enjoying watching this channel, and I mean, you may be doing a lot of other things as well. But yeah, what I'm trying to say here is having a hydrogen attached to any of these three atoms. What of these three atoms? Hydrogen attached to either oxygen, fluorine, or nitrogen. If you have hydrogen attached to any of these three and you're bringing any of these three closer, what would happen? There would be an attractive force that would get generated. What kind of attractive force, sir? Opposite charges would always attract. Even if it is not complete, they would attract each other. So this partial charges of the highest form is present over there. That would result in this powerful attraction, guys. And that is the cause of them to be so strongly held there. And this is what brings them together. And that is why alcohol is added to water. It gets mixed up with it really well. So we also use that to dilute it apart from mixing it. Well, I mean, if you would have heard people doing that, then in sanitizer also many people would add alcohol right nowadays. When the sanitizer is going to be this much and we want it to be looking to be used a lot. We Indians have that tendency. I do have that. But yeah, and now if anybody of you do that, but then what I want to tell you is they do get mixed up. If you're doing that to a limited level, that is okay. That isn't going to affect the effectivity of that substance much. Yeah, it would decrease its effectivity because the amount of that would be decreased. But then yes, it could be useful even then. Okay. So what I want to tell you is solubility would get decided by the attractive force in the molecule. If anybody would ask you, sir, if anybody would ask you, how do you decide the solubility? The first question that you should talk about is, are you talking about the solubility of covalent compound or an ionic? Or any compound also, if you talk about solubility, it basically depends on multiple factors. These multiple factors are limited. One factor is the attractive force that holds the molecule that you're dissolving in water. The second factor is how well that water or that solvent stabilizes the ions that gets formed if they get converted to ion. Okay, these two are one of the important, two of the important factors. But there are cases where this third factor also comes up. That factor is the one that I've just talked about. How well the molecules get interacted. Three factors are there that could help you understanding the solubility. These three, two are the ones that most of the times gets asked or gets used. If your teacher is telling, they will tell you this two also. Anyway. So we'll observe now that we have understood about how, what, and what is the nature and properties shown by alcohol, we could now understand the way you prepare them. Okay, children? Hello, Abhay. Hello, Krishna. Yeah. So how do you prepare them? To prepare them, there are different type of methods. One by one, we will look at them. First method, or one of the method, not the first method. Yeah, you guys might have heard this guy's name many times by me, that this person was really a good person, and not good person. Mind-wise, he was good, So what this guy did was he discovered something called an organometallic compound. What is organometallic compound? Remember, it is not oregano. Yeah. So organometallic compound literally means having an organic compound attached with metal together. And what is the benefit of having an organometallic compound? The benefit is you could generate something really unstable. What is the benefit of generating something really unstable, sir? Let us just understand that as well. If you generate something really unstable, that is going to be very reactive. And having something very reactive can have a lot of possibilities, a lot of profit and losses. Let's see what. So this alkyl group, since it is attached to magnesium, it is a really highly partial negatively charged. So when this bond gets broken, children, it gets R-. And this R- is the one that does everything. Now, one thing you should note here that I've already taught you earlier. If you missed that, do check out the previous lectures and the description below. Okay, we have the whole lecture series of IIT JEE preparation. Do get benefited from that. Whatever effort we are putting is for you and is only for you to get benefit. So if you want to get benefited, do check out if you have missed something. Okay, coming back to that. This R- will show the action that would cause these alcohols to form. You could just see, depending upon what it is reacting, it could give you different types of alcohol. Okay. So let's just see the reactions. After the reactions are over here, I'll tell you the mechanism. We'll first understand over here itself, how does this R- work? R- want to be stable anyhow. Okay. And one problem is you can't use this Grignard reagent in the presence of water. So why can't we use it in the presence of water? Almost all the reagents we use it in the presence of water. But then why not this? I'll tell you why. Reason is really simple. Now you are very unstable and you see something that could stabilize you. You take that up, right? I'll take that up. So that's what this R- does. It sees that there is a partial positive hydrogen. Why not take that up and attach with it so that R- gets stable? I told you earlier, R- is something really strong as a base, as another reagent as well. So understand, if you have R- that wants to get stabilized anyhow, and the first thing it would seek is an acidic hydrogen. I've been telling you multiple times, children, about acidic hydrogen. I hope that would have got into your mind now. Okay, acidic hydrogen. Could anybody tell me what is acidic hydrogen, guys? Acidic hydrogen is any hydrogen that is attached to an electronegative atom. Hydrogen attached to an electronegative atom are called as acidic hydrogen. Sometimes it is even attached to a triple bond. That could also be called as acidic hydrogen. Attached to an electronegative atom. And it is really important. It doesn't feel like it is important, but then yeah, it is, children. Why? You'd come up above, you'd understand about it. as you go through the flow of organic chemistry chapters. So this hydrogen was acidic and that has been taken out by this alkyl group very easily. Once that happens, what would be the benefit? What would be the outcome? The outcome is going to be RH that is going to get generated. Okay, and this is it that is important for us. Yeah. Now, sir, if this is the case, wherever you take alcohol or maybe water or whatever thing that have acidic hydrogen, if you add it to RMgCl, the only product that it would form is alkane by taking out that hydrogen. So you have to be extra cautious here that you shouldn't add water. I mean, in all of these reactions, you could just see that there are 1 and 2 written. What is the meaning of that? I've already told you if you don't remember. 1 literally means this one would have happened first, and only after the first reaction happening completely, the second reagent would have been added. That is H3O plus, an H plus ion. I mean, you're providing it with what it needs, right? But in the second step, if you'd have done that in the first step, alkane would have been the major product or the only product. What does this mix represent? It represents this two, just these two things. Let's see the mechanism of what happens if they don't have, if the species with which you are reacting doesn't have acidic hydrogen. So this, I mean, one very important thing that to be taken care here is the species with which you're reacting this Grignard reagent should lack acidic hydrogen. So they lack acidic hydrogen. This is really important to be the case, otherwise things would result into different outcome. Now let's see, because it lacks acidic hydrogen, it doesn't have an opportunity to have that happen. Hello Ninja, what graph do you want, child? Yeah, so let's just see, if you have R minus and it is going to react with this thing. Hello Ninja, how are you? Welcome to the session. CH3, CH3. Let's say you have something like this, or let's just say you have a hydrogen over here. This hydrogen isn't acidic again. Yeah, I'm good Ninja, how are you? Yeah guys, do let me know your name so that I could remember your name. Yeah. So this R minus would make an attack over here. With that attack happening, this oxygen would gain the electron density. That reaction is very obvious and this happens really often. Why does it only attack over this center? Why not over the terminal carbon? Why not over this carbon? That also has a reason. Let me tell you that. Good to know, Ninja. So CH3C double bond OH. Now, if you look at this carbon, since it is attached with an atom that always seeks the electron, because of that reason, the carbon at the bottom is really sad or positive, because all the electron density has been taken up, not all, almost all has been taken up by this oxygen atom. This has taken up whatever is there as an electron density shared between this carbon and oxygen. It moves all towards oxygen. Because of that reason, this carbon has become so positive, and that is the reason why that atom would get attracted. I mean, would attract the electron density. It's obvious, right? So that is the case. Yeah. Hope that is one thing that you've understood. But if that is happening, what is the outcome, children? The outcome is CH3CO minus, a hydrogen over here, and hello Triloknand, Dubey, how are you? I couldn't understand what is 5 plus 6, 5. But anyway, yeah. So here what is happening here is this R group comes over this place. Okay, over this place. And that O minus gets generated. But is that O minus stable, do you think? I mean, yeah, comparatively stable without with comparison to a positive charge. But then a charged species isn't anyway stable. So that would want to be stable. Okay, Triloknand, I mean, if you guys aren't aware, children, do know that we have 2 batches running, and in both the batches we'll give everything in free or for free, and one batch would be in Hindi. Okay, we have JEE Kitchen that is going to be in Hindi, and one batch, the IIT JEE Achievers, that is going to be in English. Okay, Triloknand. So whichever batch, I mean, this is only going for IIT JEE particularly. So whichever batch you guys feel comfortable, you could attend any of them. Hope you've got the answer. But anyway, this batch is particularly in English though. The JEE Achievers is in English. The JEE Ki Jang is in Hindi. Anyway, moving back, yeah, I could take up your doubts though, in whichever language you wish. So what is happening over here is this isn't stable. So to become stable, the second reagent now comes up, children. The H3O plus would now be doing its work, or actually this the class is for 12th and 12th pass out, and even for 11th people who want to understand chemistry, right? So what happens here is this O minus would make an attack over the hydrogen, and this positive charge gets nullified, and we get the final product, children, that is CH3, COH, H and R. Ultimately, this is what is going to be produced. Hope you've got the idea, guys. So this is how the thing happens. This is how the work covers up, the whole process occurs. Now, this was the case with an aldehyde. What would happen if you do the same with a ketone? We'll check that out as well. Let's do that. I hope you've got it. I'll just erase this part so that I get some space to be used up here. We'll just see this R minus now reacting with C double bond O, R group, another R. Now just imagine, now here, when no difference would occur, just the attack in the same manner, but yeah, over here it would occur, children. It would occur and this electron density moves up over here. Now there is this variation between this and this that can be asked in IIT. We'll talk about that in aldehyde chapter. They may ask you which one do react faster. This one reacts faster or this one reacts faster. If you guys can find out, would aldehyde be reacting faster towards Grignard reagent or ketone, do let me know in the chat box or in the comment section or in the Telegram channel, for which the link is also below, as well as we'll be showing it. I'll understand that you guys are doing some work on your own, as I've already told you. If you want to learn something, you have to do it yourself. No matter how much your father teaches you how to drive a car, unless you try it, unless you try to move it here and there, you won't learn it, right? You have to do it yourself. So what happens here, guys, is this makes a move over this place, and that's why this R comes in and you get this RCR and again O minus. But then you want it to be stable. What would you do? You add on H2O. Even adding H2O with this should be fine. But you add an acid, that would be more than fine. Okay. And with that, hello Suraj, how are you? Welcome to the session, guys. Well, not just you, all of you. So what has happened over here is this would make the electron density move to hydrogen. And that would get this hydrogen come up. Always remember, children, many people think that hydrogen moves up and goes somewhere. That never happens. I've told you in chemistry, the flow would always be same. Electrons would always move from a center of high electron density to a center of low electron density. If anybody says hydrogen moves, you should understand hydrogen can't move. It's the other negative ion that goes and takes up by giving the electron density to hydrogen. Okay, so that is what is happening. And arrows would always represent something. You can't make an arrow from hydrogen to oxygen. Why? Because electron density aren't there at hydrogen. So this is going to be the outcome, children. And we have got an alcohol again. If you observe the alcohol over this place and the alcohol that I've just formed, you could observe one thing. This alcohol is a secondary alcohol. This alcohol over here is a tertiary alcohol. Okay. So with an aldehyde, you're going to get a secondary alcohol. With a ketone, you're going to get a tertiary alcohol. Hope you've got the way the reaction occurs, right? So this is the catch that I have been trying to tell you. Now, if in case it is reacting with formaldehyde, it does not have any carbon attached to that carbon over the center. So what kind of alcohol it is going to give you? There's no question about it. Primary, right? Hope that made some sense and you got an idea. How does this Grignard reagent work out? One more important thing here, children, is the reducing agent like LiAlH4. You might have heard of lithium aluminum hydride. People may also call it as LAH. Many short forms are there, right? Nowadays, people like short forms more. So what happens here is this H minus ion is going to be there. And every reaction that they show is same as that of how R minus attacks. You are not going to remember, you don't need to remember how do, I mean, what is it that causes what. We should know how does it happen, why does it happen. Once you know that, I'm assuring you, you don't need to mug up organic reagents. You understand the flow, find what is coming out of that reagent, and that then use that. Definitely you get benefited without mugging up children. Cramming is not always the way. What is the way? Understanding. Cramming means you don't need to be mugging up something. You have to be understanding it. Now this is the one about which I've been talking up in the previous sessions as well. Hydroboration, oxidation of alcohol, of alkenes. How? For the preparation of alcohol. For the preparation of alcohol, this hydroboration oxidation reaction occurs really commonly. How do they occur? What is it that occurs in that? And what is the manner in which they get proceeds? I mean, they proceed. Let's see that. You all know that electron density is present over this alkene that would move to the boron atom. You know, boron atom wants only to be attached over the terminal. Okay? Why? Because this is this bulky group over here. It cannot go there. It gets hindered. So when this molecule wants to get added up, this boron comes over here, hydrogen comes over here, till all the groups gets added. So this happens 3 times till this bond gets created, 3 with 3 such groups. Okay. Till all the hydrogens of that boron atom gets away, this thing repeats itself. So this reaction would occur 3 times. The boron and hydrogen would show addition reaction with alkenes 3 times, replacing all the hydrogens present in boron. And this part of the reaction from here to here is called as hydroboration. Okay, this is just the hydroboration, the first part of the reaction. Okay. Now why and where does it get added up is this. Now this is not as stable. I mean, this is again not stable. One more thing, children, you may have been thinking, what is this THF? Why is it that? I told you BH3 earlier is unstable. And if it is not stable, you want it to be there. And if you want it to be there, you need to somehow stabilize it for some reason, right? Otherwise, it would not be there anymore. To stabilize that, what we need, children, is something that could provide electron density. Tetrahydrofuran, THF, does the same. Okay, this tetrahydrofuran gives them the electron density, and that causes this to happen. Fine, then let us just understand what happens next. So we have got till this stage. Okay, here they've just told you this 1 times. This happens till all the hydrogens of this repeats, I mean, replaces itself. So this reaction happens 3 times. And after having it happen 3 times, you end up getting this B, C, E, CH, C, CH3, CH3, same way CH, C, CH3, CH3, same way here, CH, CH, C, CH3, CH3. You would get this. If you'd get this, do you think this is stable? What is your guess? How do you know if it is stable or not stable? To know if it is stable or not, what you should check out is how many electrons are there with this boron. If you'd cross-check, children, you'd get this boron only has 6 electrons, right? This boron only has 6 electrons. If it has just 6 electrons, to be stable, it wants more electron density. And that comes up in the second part, the oxidation part. Okay. So in the oxidation part, what is going to happen? This H2O2 in the presence of OH minus comes in. Okay, how do they come in? H2O2 comes in like this, children. Electron density of oxygen makes an attack over this boron, stabilizing it. And I mean, I'll just talk about the major condition. Once that happens, children, they would get attached. Okay? And you end up getting this B, and this I'll just draw this alkyl group in this manner, so that it becomes easier for us to understand. Otherwise, like I'll be just drawing it multiple. A lot of amount of time would just go in that. So what has happened is this. Now, as I told you, this O of H2O2 has bonded over here. Hydrogen will be taken out by OH or something, and would get attached in this manner. So after getting attached in this manner, this bond is a weak bond, and you still have OH minus and water or some other reagents present. Majorly OH minus still present. You'd get a negative charge over the boron and a negative charge over the boron, and for some time a positive charge over here as well, because that hydrogen is still intact. Now what would happen is this OH minus can do two things. One is it can take out the hydrogen and then it would do the process. But the second one is it could make an attack over the boron, cause this bond to be broken down, and with that attack happening, what would literally happen here is this. This molecule would break in this manner, giving it an OH group over here, right? This would gain the electron density, and this OH would now replace this position. So you get this molecule and an OH group over here. So this bond breaks up again, okay, in one way that this would result in formation of this. Is that clear, children? So what has happened here is, once this makes an attack over here, this bond initially breaks up, or this bond shifts to this place, we can say, and that would result in the formation of this OH over the terminal. And this is what would get created. And ultimately, if you see over here, the OH has come over the terminal. And this happens 3 times, since 3 of these groups are there, right? So that is what is important. 3 of these alcohols would get created. 3 more of this molecule gets created. So this is the way the whole reaction occurs and the outcome comes. This is how oxidation, hydroboration oxidation works. Hope it would have made some sense and you would have understood how it actually occurs, right? So this is what happens is OH replaces, or OH gets attached with this bond from here after getting this OR attacking. Like till this we have already got everything. Where were we? So we had this RROO bond, and now what has happened here is this bond, this R group would move to this oxygen, since this oxygen would tend to get a positive charge if this bond breaks up. So instantly, to neutralize it, this alkyl group moves over here. Okay, in Beckmann rearrangement also we have this type of movement, and that caused this OR group to form. As I told you, this happens 3 times till all the group changes to OR. Once all the group changes to OR, this OH comes again and it attacks the boron now. When it attacks the boron now, this bond comes up alone as this RO minus, which would take out hydrogen and would result in the formation of alcohol. Total, how many moles of alcohol would get generated? 3 moles. And what would be the side product? H3BO3. Okay. So this is the case that you would need to understand. Hope this had made some sense and you've got the hydroboration oxidation reaction clearly. Okay, then let us move further and understand the next thing. The next way, children, is by hydrolysis of alkene. This is not an unusual reaction. It's a very simple SN2 mechanism, where what happens? A nucleophile attacks and the leaving group leaves. So this makes an attack and this leaves. So this OH comes up over the place. 90% of the product would be this. What is the other 10%? Alkene that gets formed when you remove this hydrogen. You remember the elimination product and substitution, they compete. And I told you, how do you compare that as well, right? Many times you have to compare, would it undergo elimination and give an alkene, or would it give an alcohol as a major product? That you would need to compare which one happens more easily. For that reason, we know the comparison well with the way we compare, the things that we use in order to compare. Right? So hope you'll be using that, and with that comparing them would become easy. Anyway, let's move further and try to understand the next thing. Yeah, there are some industrial preparation methods that are of no use for us. Just knowing them is good. So you can prepare by this process and the control. They are not so important. You could also make ethanol from the crude oil. Okay, you could do the cracking and convert them to alkene and then just react it with water. So that's a very simple method of hydration of alkene. With that, you could prepare an alcohol, which we had seen earlier. But yeah, this is okay method. They're not important for IIT JEE a lot. But yeah, knowing them is definitely useful. So that is what is happening here. Now comes the last part, not the last part, one of the very important part. Having the reduction of alcohol, aldehyde, ketone, esters to an alcohol. In that case, you would need something that we call as reducing agents. With this reducing agents being there, you could really easily, very easily, be reducing a substance to an alcohol. What are these reducing agents, sir? How do we identify that we have a reducing agent? Hello Surya, hello Suraj, how are you? To identify a reducing agent, you would need a very simple thing. What is it? Check out that it has hydrogen attached to a metal. How does hydrogen attached to a metal cause reduction? That's one of the reducing agent again, and more. But how does a hydrogen attached to a metal cause reduction? I'll show you that first. LiAlH4. This is one of the strongest reducing agent, children. We call it lithium aluminum hydride. Now, how does this lithium aluminum hydride helps us? I mean, what does it do? How do you know that this is going to be a substance that could cause a reduction? We know it because if aluminum and hydrogen are attached and this bond are going to get broken down, hydrogen will take up the electron density. It would become, I mean, it is more electronegative than a metal. So it would take up the electron density, and for that reason, it would become negatively charged. So just imagine if H minus is there, H minus would again be acting like that of R minus that we started the reactions with, the preparation with, like that Grignard reagent. The only things that it would seek is either an acidic hydrogen, or a center with a partial positive or complete positive character. In the first molecule, this lacks acidic hydrogen. So there is no question about what attack it is going to do. It makes an attack over here, causes the electron density to shift to oxygen. Once that shifting of oxygen happens, children, what would it result in is this. Let's see. So this hydrogen comes up, this R was as it is, this hydrogen was there over here. So this new hydrogen, I'll make it with green color so that we can see that clearly and observe that. So this hydrogen comes up over here, and initially this oxygen gains negative charge. Now as it has got a negative charge with something like water or something, it could easily gain the hydrogen and get an alcohol formed. So what has happened here? You have got a primary alcohol formed by this method. So remember that depending upon what is your need. We have got another question now. Sky Gaming is asking, sir, can we take NaBH4? So if you want to take NaBH4, children, you could take that. But then there is a problem. Like right? Some reagents are weak, some are strong. So how do we know which one is weak, which one is strong? Let's see NaBH4. Good question, Sky Gaming. And guys, do let me know your name, children. So if you take NaBH4, what happens is there is a problem that comes. Problem is this. Let's just write NaBH4. If you see NaBH4, you could see hydrogen is attached to boron, right? If hydrogen is attached to boron, children, you could see boron is more electropositive or aluminum is more electropositive. You tell me. Definitely aluminum is more electropositive because boron is less electropositive, guys. If it is losing the hydrogen, it would not lose it with as much electron density as how much you have with aluminum. What do I mean? What I mean is, you just check these two things out. ALH and BH. So here the bond has more electron density shifted towards oxygen. Here the bond has more electron density shifted towards oxygen compared to the second one. So when this bond breaks, or it breaks very easily with H minus compared to BH, which breaks a little slow, which doesn't break as much with the negative charge over hydrogen as much in the previous case. For that reason, hydrogen over here is really reactive, hydrogen here is less reactive. That's why in aldehyde and ketone, in first and last, H minus from NaBH4 can also show the product. But in carboxylic acid and ester, NaBH4 isn't going to be used. And you know, IIT JEE knows that student would do a mistake here. So I'll add on the things that could reduce them and that can't reduce them. At least NaBH4 and LiLH4. So remember that if you're using LiAlH4 children, it would reduce all of this carboxylic compounds. Aldehyde, ketone, carboxylic acid, esters. LiLH4 converts them all to alcohol. NaBH4 is a little weak reagent. It can only convert aldehyde and ketone to alcohol. So I hope Sky Gaming, your doubt is clear and rest of the students would have also got benefited with this question. It's a really good question, Sky Gaming. So that is the catch, children. You should understand that reduction is a very common phenomenon, common thing, and what you would need in order to reduce something is a reducing agent. How do you identify reducing agent? Almost all of the reducing agent has this hydrogen attached to a metal, but not all. There are cases. You may say H2 and PD. This is also a reducing agent. Okay, so many reducing agents are there. Many would come up more in the further future. I'll tell you about that as well. Different reducing agents would have different nature. Different oxidizing agents are there. That could do the reverse. You have an alcohol, you take an oxidizing agent, you convert them to the ones that is written over the other side, which we are now reduced. So that is also possible, okay? In the reaction, we'll see that out as well. So reduction of carbonyl compounds gives alcohol. I hope you've got the idea. It's really, really useful and important to understand this. Do let me know if you have a doubt, like how Sky Gaming asked. Check out and find out your doubt and get them clarified. Yeah, with that known, we have come up to the place that we could try some problems. Okay, now the problems that we would try, yeah, one more thing, children. I had not emphasized a lot on that point, but yeah, I'll move back and I'll do that part a little bit again. You remember about hydroboration oxidation. I told you in hydroboration oxidation, I'll just erase this part over here so that we get some space to talk about a little bit of more things here. So we do hydroboration oxidation, and in the hydroboration oxidation, you have understood about we get an alcohol. Now, where do we get an alcohol? In the more hindered place or in the less hindered place? You tell me. As the boron has been attached to less hindered place, children, the alcohol would also get formed over the less hindered place. Hello Bhavesh sir, जिंदाबाद. क्या चीज जबरदस्त, क्या चीज बस करना है. अब थोड़ा सा और समझ लेते हैं. I mean, let us just understand a little bit more and then we will stop. Okay. So what has happened here in the presence of boron, I mean BH3 and THF and H2O2 and OH minus, you get OH attached over less hindered side. Now just imagine if the second set of reagent isn't H2O2 and OH minus. You take H2O2 but you take an acid instead of a base, you take an acid here. You know what you would get? Instead of getting this, you would get an alkane. CH3, CH, CH3 and CH3. You know, this point is really important because in the last step, thing changes. That OH wouldn't come out without the presence of a base. If you take an acid, you would end up getting an alkane. This point is something that you should feed in your mind properly, children. Okay, so what has happened here? This is going to be created. Alkane is going to be created. So I'll just write it down for your understanding. If the reagents are BH3THF, BH3THF, that's the first reagent. The second one, H2O2OH minus, then you get an alcohol. If the reagent is same, again, BH3THF, this part, everything is same, okay? BH3THF is same. The first part is hydroboration part is same. But the oxidation part, without the presence of a base, but in the presence of an acid, would result in the formation of an alkane. So this is also a way of preparation of an alkane cell. Okay. Actually, that negative ion gets formed, and the negative ion would be, I mean, after this gets formed, this gets removed also, you can say. So this would ultimately lead to the formation of an alkane. So hydroboration oxidation gives you an alcohol over the position which is less hindered. This is one thing that is to be noted apart from the one that I just told you, less hindered. Then there was another thing which we had already learned, oxymercuration, demercuration. HgOAc twice in the presence of NaBH4. Okay. In this case, you know what happens, children? And here also you need OH minus. In this case, what happens, or H2O? In this case, again, you get the alcohol over more hindered side. If you remember this reaction we did in alkene or alkyne chapter, more hindered position would get an alcohol. So this point is really important to be noted. The reason being, this Hg binds up to the double bond in this manner. Let's say you have C double bond, children. What happens is one of the bond breaks up and this Hg plus would get bonded. So what happens is this H2O comes in and get attached over the top. So this is how the reaction proceeds, and you could understand that it would go and attack over that center where positive charge would be more stable, unlike in BH3 where OH would get attached to that center where it is over the less hindered side. This is a point that everybody should catch. Wherever positive charge is more stable, in oxymercuration, demercuration, that alcohol would form. Now we'll move back to the problem that we had. Do let me know if you have any type of doubt anywhere, children, so that we could rectify that and get you an answer to whatever you need. So let's just read out the question. The question says, which of the following reactions does not give 3-methyl-butane-2-ol? Now what is 3-methyl-butane-2-ol? First draw that as main product, major product. Butane-2-ol, we'll draw that first. 1, 2, 3, 4. 2-ol, OH. 3-methyl, okay, CH3, 3-methyl. This is 3-methyl-butane-2-ol. We want to prepare this. So which one would not give you this? First one. If first one reacts, you get an alcohol over a place where carbocation is more stable. Okay. Choline does not give 3-methyl-butane-2-ol. Okay. So one of the products here, once this gets attached in this manner, H plus comes over here, one of the OH comes over here. Although there could be a carbocation shifting that is possible and would give you 2-methyl-butane-2-ol as well. Second one we'll check. Second one, no doubt, it would definitely give you this. Third one, HgOC, you know for sure that it would initially give you OH over here and over here as well. Why? Because it is more hindered comparatively. HgOC, oxymercuration, demercuration. Next one is this HgOAc twice, and like you could just see the double bond is over here. In this case, definitely OH is going to be prepared over this place, right, children? So we could just see which one will not give 3-methyl-butane-2-ol. We know for sure that here OH is only going to be formed over this place, and it can't be formed over this place, which is what we need as here. So D option seems to be the one where there is no chance of that getting, that OH getting formed over the place where we need it. All the other ones do have a chance, right? Second one will definitely have that one only. The other ones do have their chances. So we have now understood how does it happen? How does it actually happen that you get the alcohol over that place? So this is the catch. And that's our answer. This is it. Now I hope you would have understood the things that I've talked about. You would have got the idea how does this happen. Yeah, I was not able to do all the mechanism to the level that you would need because time is another constraint. But yes, if there is anything that still is troubling you, do let me know either in this Telegram channel by scanning it, or you could write in the comment section of all the videos that we have uploaded and had been live earlier. Also, you could subscribe to the channel so that you could all get the things that comes up to the channel as we would upload it. Whatever we do, we put our efforts for you to gain something. We could like check that out, and yeah, subscribe as well as share it to your friends so that they could also get benefit. Hope you've understood the things. Thank you, children. Let us just meet again in the next session. Hope you'll be live. Take care. Bye-bye.